Hi, today we meet up again. Today we're going to cover chapter 12, correlation and regression. Now you're going to prepare two pieces of A4 paper, a calculator, and a pen. Remember the WhatsApp between the boss and the staff happens again, and the date is 28th of December 2020. This is the boss. Hey, your sample 15 times 4 experiment shows fertilizer L is the best one? Staff. Right, boss. What now? After 3 minutes? Boss, you really want me to do the very last experiment, the 1000 times 4 experiment? But I already proved that fertilizer L could produce, in average, the highest spinach, boss, and I used one-way ANOVA to do so. Relax, man. I'm convinced with your findings. Now, go and check. If I put more fertilizer L, could it produce higher spinach? Oh, boss, I got no more money. This time, can I do a simple one like just testing only 5 spinach plant? Hey, you say you know inferential statistics tools. Use it then. Okay, boss. I will do the experiment tomorrow morning. I promise. It is tomorrow morning, Wednesday. Boss, actually, how to start the experiment? Today, you go and set up 5 spinach seed pots. After 1 minute, you apply a different weight of fertilizer L. Then you just wait until mature day. That is end of January. Measure the height, okay? And then give me 2 reports. The first report, is there any correlation between fertilizer L weight and the spinach height? Second report, you find the regression and predict if I apply 50 gram, what would be the spinach height? I want those reports by 1st of February 2021. For this problem, the staff need to prepare 2 reports. The first report, if you put more fertilizer, more budget, will the spinach plant grow taller or no? The second report, if the boss put 50 grams of the fertilizer, what would be the expected height of the spinach plant? It is 1st February 2021. This is the date where the plant already grow maturely, and then the staff he go and measure the height of the spinach plant. Boss, 5-part experiment completed. I've collected the data and I use the Pearson correlation test to find the relationship. This is the 5 parts experiment. And then this is the result, yesterday one, when the spinach grow maturely. And I found that the first pot, the spinach plant is 8 cm, the second one is 9 cm, the third one is 9 cm, the fourth one is 11 cm, and the last one is 13 cm, boss. And I put it into the table form. Is it nice, boss? And then this is the way I calculate the Pearson correlation test. At the end, I got the value 0.7906. Here, boss. This one. Hey, why you use that what so Pearson called test? No other test you use. Tell me why. Oh, boss, let me explain. Because my independent variable, that is the fertilizer weight, is a ratio number, and then the dependent variables, the spinach height, is also the ratio number. Plus, my intention is to find, is there any correlation between those variables? See, boss, when I did the calculation, I found that 0.7906, it is a strong correlation, boss. But I need to tell you one thing, boss. It is only applied to this 5 ports case only, not the 1000 port. Okay, boss? Please be noted, boss. One thing, boss. I think I cannot give you the report 1 and report 2 because at the end, when I did the significant test, I found that there is no significant result, boss. And the 0.7906 strong correlation cannot reflect the 1000 port case. I think maybe my experiment got some error. How about let me try a new experiment tomorrow? Here is how I find the significant result. At the end, I found that the value 0.706, it is lesser than the critical value was 0.878. That's why I say that my result is not significant and it cannot use to predict a 1000 case problem. Since the value of the R obtained by the staff is very small, 0.7906 only, and the critical is 0.886, it means that his result is not significant, or to say that he cannot use his 5 ports simple experiment to expand it to reflect the so-called population experiment. There may be error, or else there's no correlation at all. So the staff proposed to do a new experiment to check whether is it because of the error or is there really a correlation between the weight of the fertilizer and the height of the spinach plant. So this is the new experiment and the new result. So he put 20 grams, he found that it makes the spinach plant grow 82 cm. He applied 16 grams, it makes it grow 70 cm. He applied 24 grams, it grows to 90 cm. 22 grams, the height is 85 cm. If he puts 80 grams, the height will be 73 cm. Now it is your turn, the student turn, to fill in the blanks for the gray color boxes there. Okay, later on you're going to do the calculation and then fill in the value inside here. Why? Because the value inside here, it can be plugged into this formula. So what is this formula? This is the Pearson correlation test formula. It used to find what is the value of the correlation. Okay, after you plug all the summation of y, summation of xy, summation of x squared, summation of y squared into this formula, and then you're going to get a number. So do you get this number 0.9862? And then what is the strength of this value? Is it considered strong, or is it considered very strong, or is it considered weak? And then check that whether this number 0.9862 is it significant or not. Because the case is still the same. We have total of n equals to 5 experiments. Then we want to use the we want to use the table to find the value of the critical R. The critical R will be 0.878, and then the R that we calculated is further than the critical value. What does this mean? It means that our result this time is significant. It means that we are going to reject the null hypothesis. So what is the meaning of so-called rejecting the null hypothesis? It means that even though we just conducted a 5-pot experiment, but our result, our R, that is a strong correlation between the fertilizer, the budget weight, and the height of the spinach plant, can reflect a 1,000 pot case. It can reflect a so-called population experiment case. Since our result is significant, now we can proceed to find R squared. And also we can proceed to create a model and then do the prediction. When we impose a 50 gram of the fertilizer, what will be the height of the spinach? So R is above here. Where can you get it? From the formula here. Where can those numbers appear inside the formula? You can get it from the table here. Okay, we got the R equals to 0.9862. It is a very strong correlation. How we know? Based on the general table here. It is a very strong correlation. And then R square means what? We get the number first. R square, after we square the 0.9862, we got this number 0.9726. What does it mean? It means that 97.26% of the spinach height, the height here, the height there, this height, those height, that height, is totally because of the fertilizer L. How about the remaining 2.74%? Then 2.74% of the spinach height might because of the other factor. Maybe there are more worms inside one of the soil. It causes one of the pot producing a higher spinach plant there. Now we got the R2. Let us help our boss to do the prediction. When the weight of the fertilizer is 50 gram, what would be the expected height? This is called the regression test. So the regression test can be expressed in the formula here. Y equals to A plus BX. Where can we get the A? We can get the A from here, the general formula. And some of the value is taken from the table here. How about B? B is represented by this formula. Where can we get the numbers from to plug in? From this table also. See, this table is very useful. So next time when you encounter those kind of problem, you need to find the correlation or the regression, remember this table. Quickly create this table and then quickly define what is the summation of x, summation of y, xy, x squared, y squared. And then pull back the formula of the regression, the correlation, then you can get the final value there. Okay, let's proceed. So we already know our B is 2.6 and then we already know our A is 28. Now we're going to put everything, A and B, into the general formula here. This is A, sorry. Okay, you put inside A and you put inside B. So we have a more details how to say, least square regression line here equals to 28 plus 2.6x. What's the use of this regression line? It can use to predict when the boss want 50 gram, what will be the new height of the spinach. So he want 50 gram, no problem. We will plug in 50 gram into x, and then we will find what is the y. Y is the spinach height. Simplify in the value, and then we get the height of the spinach plant expected to be 158 cm. This is only a theoretical calculation. We never see a spinach as tall as a human being, right? Now, the staff can have a very convincing report to his boss. He will say that, oh boss, report 1, I give you the conclusion. The fertilizer and the height of the spinach plant have a very strong correlation. And then the report 2, since you want to know 50 gram fertilizer, yes, we're expecting going to get the spinach plant as tall as 158 cm. This is your first task. Question 1, you see the green color on top here is a bit small. Okay, now we're going to bring out your first piece of A4 paper here, and then you're going to copy the whole process at the column 2 and then at the column 3. If it's a bit messy inside the slide here, you can go to the PDF version, and then you can see the more clearer font inside there. Let's go to another slide. Oh, it is our tutorial session. What you need to do for your tutorial, this is your question 2. You're going to find 1, 2, 3 by hand at your second A4 paper. No need to copy the question. Okay, later on you just solve 1, 2, and 3. A research was conducted to determine the relationship between the numbers of members in a household and their monthly expenses on water bills. Means that if the house got 4 people, is the water bill going to be like increased when they have extra 2 members join into? The following tables shows the data collected randomly from 10 households in Tanah Merah area. House number 1. This is house number 1, and then they found that there are total 2 members inside there. And then they ask, hey, what's your monthly water bill average? They say, oh, 30 ringgit. And then they go to the next house and they ask the father, and the father said, I got 3 people in the house, and then average we spend 44 ringgit. Then they walk around, and then they reach the last house, the 10th house. So the students sweating around because it's very hot outside, and found the last house contains 6 members. And then they ask, what's your total expenses for your water bill? Oh, 58 ringgit. Now, you need to identify what type of the data you have for this one, the household. It is a number. Does it contains negative? No. Since it doesn't contain any negative, we only have one option. It is a ratio data. Now we still have one more mystery to solve for the number of members in a household. This is a variable, something that we don't know. We go to the first house, we don't know how many family members inside there. But is it so-called independent variable? or it is a dependent variable? We are expecting it is a independent variable. Why? Because if got people, then we're going to have the water usage. If no people, no water usage. So this is an independent variable. Let's go to the third column here. Monthly water bills. Let us check at the data here. So is it a number? Yes, it is a number. Is it does it contain a negative value? Seems like no, because we exclude the so-called how to say, owning the air kelantan case. Let's say we just considering the water bill, each bill stated inside there. It's always a positive, and sometimes it's zero. So this is also ratio data. The second column here is the independent variable. So this one will be dependent variable. Means that the monthly bill depends on how many people inside the house. Okay. We want to find, is there any correlation between the members in the house and then the water bill? Or to say that more people, is it higher water bill? First one, you want to construct a plot of pair observation for the data. Okay, this one you're going to build the table later on. This is a very crucial, important tables. You have the summation for the x, summation for the y, and so on. You can refer to the previous problem. And then B, you want to find the product moment correlation coefficient. This is also so-called the Pearson correlation. You want to find what is the R. After you plug in the value from the one here into the Pearson correlation formula, R equals to the sigma, you're supposed to get what value? You're supposed to get this number. R equals to 0.9450. It seems that this is close to 1, or to say that it is a highly correlated value here, or to say there is a very, very strong correlation between the household member and the water bill. It means that if I have 59 people staying inside one house, we're going to have a very expensive water bill. The third one, you want to find the linear regression equation of monthly bills in a household. Estimate the monthly expenditure water if there is how many? Not 59, but this problem asks us to find 9 people inside the house. So you want to find 9 people. We want to guess they need to pay how much every month. So you're going to get the regression equation first, and after that what you do is we're going to plug in 9 into which one? Yes, x. We plug into x, we're going to get here. It means that if we got 9 people in one house, we're expecting the water bill will be how much? 102 ringgit. Okay. This is your Q2. Do this one, no need to copy question, just solve it 1, 2, 3, snap photo, and then submit at the link given later. Now we go to the 25% project section. After 2 weeks from today, leader going to submit the full report of this project. We're going to go to the idea how you complete the report. You complete the project. Project is 25% from your total assessment. you're going to have total 5 members inside one group, but few groups going to contain 6 members because there's some extra numbers. You see that there will be a leader, and then there'll be 4 members. The leader for group F01 is who? Abdul Rahim. Abdul Rahim, are you here today? And then you have for your 4 members going to support the whole group here. You can get the team members inside the PDF. Later on, I'll show where can you access the PDF. This is the second page from your PDF, the template. You're going to see the instruction how you complete your project. At the end, leader is the one going to submit the whole project, and the due date is 12th of January 2021, Tuesday, before 5 p.m. The leader going to submit at this specific link here. What is the role of the leader? Leader is the one who distributes the tasks to the members. In average, each of the members, including the leader, are going to have 1 page. They're going to do 1 page each. If you have the printer in your house and it's quite convenient for you to print it out, I would propose all the members and the leader, you print out all the pages individually. Let's say you stay at Ganga, so you print it out at Ganga there. So you have the whole template with you together, because it will be more easier for you to write it down. I already assigned the gray box, the place that you need to handwriting to do the input. As long as you see, let's say page number 4, there are a few gray boxes. That is the place that you're going to write the things down. Little before the due date, maybe 10th of January, 2 days before the due date. So leader going to ask, hey, all members, completed already or not? So snap photo and then WhatsApp to me or email to me, because I want to compile all your works and then I want to submit on behalf of you. What does all pages means? Means that what should the leader submit at the end? So it will be the whole PDF that you download from the name list until the last page. The leader going to use the converter PDF, something like that, to compile everything into one PDF, okay? One PDF, and submit where? Submit here. There will be marks deduction if the leader submitted later than the due date. And one more deduction happens if the content is so-called written by typing. I only accept the handwriting. Use your hand to do the writing. 2, 4, 5. Okay. Handwriting. Okay. No computer, no digital to copy and paste. No. Instruction as below. The next slide is the question. Oh, before that, you can get your PDF here. You go to the above 3rd January and 9th January, above it, you can see the important dates. So you can download from here, the project 25%. Okay, this is the instruction. At 5% level of significance, Analyze the data inside table 1. Okay, you're going to use the ANOVA to do a statistical test. And your report should consist introduction, objective, relevant hypothesis, detailed explanation why you use ANOVA, comprehensive discussion for few of the tables, and then a conclusion. Okay, this is glue type A. Then we have the glue type B. We have glue type C, and so on. We have more than 2 groups, 3 or above. That's why we use one-way ANOVA. So one-way ANOVA, you can use any online calculator. You can use Excel. You can use SPSS. You can use even your manual way. At the end, it's going to solve for you. It doesn't matter we use SPSS or Excel. Okay, this is the first, so-called the first task, the first page, and it is exclusive for the leader only. Why for the leader only? Because leader has the big responsibility to compile everything, to do this and do that. So the leader have this privilege to do a more general task here. So the leader going to write whose name here? The leader name, leader detail. So his student ID and his name. So he's going to fill in the introduction, the objective, and the conclusion. Then this is the page for the member. So let's say the leader asks 4 members, and let's say the third member say that, oh, I'm good in this one. So the third member can be asked to fill in the gray color boxes here. So the third member is going to fill in his name here and his program. Okay, this is also another section that before we confirm we can use the one-way ANOVA, we need to make sure that the data is normally distributed. Means that our data at the end we see something like a mountain here. How can we make sure that our data is normally distributed? We can use those 2 tests here, test of homogeneity and also test of normality. Then the next member, we're going to do something about descriptive statistic. What is descriptive statistic? This is like to find what is the average, or to find what is the standard deviation, to find what is the standard error, to find what is the upper bound and the lower bound, what is the maximum value and the minimum value, and fill inside. All about the sample data. And then this member, we're going to get the value for the ANOVA and to discuss it. The last member going to do the Turkey HSD test. What is the purpose of this test? Because the ANOVA test only says that, oh, at least two glue got difference, but I don't know which one. I don't know which pair. To solve this one, we need to call up Turkey HSD. It's going to tell us which glue got the so-called difference in terms of their strength there. So after you fill in the gray color boxes here, you're going to do a simple discussion. Okay, that's all for the project. Before we wrap up, there are two big things that you need to do this week and after 2 weeks time. The first one is submit Q1 and Q2 through the link here, tinyurl.com/collaboration12345 before tonight 10 p.m. These will be the two things that you need to submit. So you have your A4 paper, and then you need to copy these two sections, and then you have the second A4 paper, you're going to solve this one. Another things is the project. Who is going to submit the project? Only the leader. Okay, only the leader. So you're going to submit the project through the given link here. What is the due date? Before 12th of January 2021, Tuesday 5 p.m. This is the project. Okay, that's for this week. I'm going to see you next week again. Okay, bye.